So if we would divide by 2, x is less than or equal to -7/2 or -3.5. So Michael, do you remember if it's an x form, will we have a horizontal or a vertical line? Vertical, yeah, because it tells you what x is. So on the x-axis, I'm counting over to -3. 1, 2, 3, and then 3.5 is in the middle. So it's weird not to have just a -3 or just a -4, but you're in between -3 and -4. And then the next question, Michael, is it a solid or a dashed line? Yeah. Why is it solid? Great. So greater than or equal to means it's a solid line. So I'm going to make a solid straight line here. There we go. Wonderful. So the equal to makes it a solid line. And then the last thing we have to do is shade. And this is the only time where you do not shade above or below, because you can't go above a vertical line. That vertical line is going up forever. So we need to think of to the left or to the right. Where are the numbers less than -3.5? So Michael, the left or the right of my graph, where are the numbers less than it? Yeah, on the left. Positive numbers are on the right. Positive numbers are big. Negative numbers are on the left, and they are smaller. So we would shade on the left side of our graph. That is the only time where you shade left or right. Any other time, it's above or below the line. So less than is always below, except when it's a vertical line. Questions? So I'm going to try and just reiterate. Please submit this assignment. Any assignment that we've done so far in chapter 4, please submit them. So we still have students like beginning of the marking period. We want everybody to have 100%. Like essentially, it's completion. As long as it's complete, you get full credit. Complete with work. Submit it on time. If it's not submitted on time, yes, you're going to lose a couple of points or a little bit, but it's still better than not doing it at all. So please submit this work. And I look at my screen, I have a whole bunch of missing. Like my screen just says missing, 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 missing. And we need to get that corrected to kind of move forward through the rest of the year. So today we are going to graph these inequalities like number 14. But now we're going to throw 2 in. And we're going to graph 2 of them.
Oh, yeah.
Yeah. So if I looked at number 14 and I'm just going to make another random line. Now we're going to have 2, and we're going to look for an overlapping region, and then that overlapping region is going to be the solution. And we're going to talk about how to find that today. So 2 lines today. Tomorrow we'll also work with graphing 2 lines, and then on Monday we'll pull in 3 or 4 lines.
Oh boy.
So tomorrow we're going to look at some special cases of lines. So we're going to do a quick little warm up just of graphing 1 line. And then we'll talk about how to graph 2. But in your notes, if you'll turn to page 14, whether you have the packet or if you're at home and you don't have the packet, but you have the notes on Notability. We're just going to go through these 2 together. And then, Mr. King, did you want to do the notes? Or
Got it, yeah, 100%.
Yeah. Can I do these 2 and then I'll
You
get
can do
it?
whatever you want. As long as it's not draw a tattoo on me.
Oh, yeah. Well, no, I promise I won't do that. Unless for some reason I'm mad and I feel like I should inflict pain on you, I guess. Huh? Haley says it's not painful, though.
Yeah, we good.
So the first thing, Haley, number 1. Do you remember what the slope and the y-intercept are here? Yeah. Excellent. So slope -4, y 3. You begin with b. So up to 3. Move with the slope. -4 means we got to move down 4 over 1. So B on the y-axis, move down 4 over 1, or we could go up 4 and backwards 1. Haley, if this just says less than, would we connect our points with a solid or a dashed line? Excellent, dashed. So a dashed line to connect our points. And then we have to decide above or below. So last time I'll ask you a question right now, Haley. You're doing good. Less than means, do we shade above or below the line? Excellent, nice job. So lightly shade, go to one of the points and go below that point on the line. So try and think you're still below or above the line. So everything below the line. Even when it's a steep line, I still want you thinking above or below. That's it. Number 1 is done. That whole region is the solution. Questions? So Michael, if you look at 2, what do you have to do with 2 first? Yeah, so we need to subtract the x. So 3y greater than or equal to, subtracting an x, I just put a 1 in front there to remind us there's a 1. And then Michael, what would you do? Right. So divide by 3. Those guys are gone. Our 3's are gone. We don't need to flip the sign, divided by a positive number. So y greater than or equal to, and then what is it greater than or equal to? Good. So that's our new inequality, that y by itself, mx plus b. So just like the previous one, m is in front of x, the b is the number hanging out by itself. Move up to b, begin at b, and then down 1, right 3. Our slope is negative 1/3. Or up 1 and backwards 3. Michael, solid or dashed line? Solid. Solid line. And then final question, Michael, greater than or equal to, is it above or below? Above, yeah. So greater than, we want the numbers that are bigger. Well, when we're talking about y, the numbers that are bigger are up. Numbers that are less than are down. So up, above, anywhere above the line. So we're going to expand on this. Pull both of them together now. Find both inequalities together.
And I'm going to show you how to graph when we're doing multiple inequalities. Both, it's a little bit easier if you're using a tablet, but I'll also show you how to do it if you're using paper too, because it gets a little messy pretty quick. I could show them how to do it, the one. So a system of linear inequalities is the same thing as a system of equation. The only difference is that you just have 2 inequalities that have the same variables. So it's just 2 inequalities that have the same variables. That's it. So when we looked above our example, we could actually combine these 2 into 1 because they both have an x, they both have a y in either one of them. So we could mark these up. You can do any example you want. So just like an example of this might be, I don't know, 3x minus 4y is less than or equal to 6, and then 2x plus y is greater than or equal to 4. So here's an example of what a system of linear inequalities is. So instead of just having one, that we're solving for y and graphing and shading the region. Now we're going to do it to 2. That's it.
Remember chapter 3, like everything we did in chapter 3 was all systems. They were equations that we were solving for.
So when we look for a solution to a system of linear inequalities, that's going to be any point that is in both of the inequalities. So like when we look above, you notice that the point 0, 0 is a solution here on the left one, but 0, 0 is not a solution on the right one. So that one wouldn't work, right? But so we want to look, where would a solution be for both of them? And then you might look at something like -5, -5. Well, that is a solution here, and it's also a solution here. So -5, -5 would work. So basically, all it is a solution to both inequalities. So any point to any point, so x comma y, and what we're actually looking for is a region. It's going to be a region. All right, so it says check whether 3, -2 is a solution to the system of inequalities. Well, to do this, all we're going to do is we're going to plug in. So I'm going to start with the first one. We have x plus y is less than 5. Well, now we're going to plug in our variables. Our x is -2 plus our y is 3. Oh my goodness. Thank you. Very embarrassing for me. 3 minus 2 is less than 5. That gives us 1 less than 5. Is it true for the first inequality? Michael? Yeah, this one's true. So I'll put a check mark next to the first one. Now we got to see, is the second one true? So Michael, what am I going to plug in for the second one? Yeah. So we plug in 3. And then is 6 less than or equal to 8? Yeah, so that checks off. So is this a solution to the system? You'd say yes. It's 3, -2. So we're just checking that one point. Same thing over here. Haley, what do I plug in for the top one? Good. All right, let's do some quick math. What's 4 times 3? Good. What's 12 minus 2? Is 10 greater than 1? Yeah. So that top one checks off. That checks off. So now we got to do the bottom one. Haley, what do I plug in for the bottom one? Good. Good. So then you get -3 plus 2 less than 1. And then we get -1 is less than 1. Does that check out? Yeah. So are these both solutions? I'm sorry. Is -3, sorry, 3, -2 solutions to both system of inequalities? Yes, it is. So nothing too hard there. But when we're going to graph a system of inequalities, we have to follow these steps. It's just solve for the variables?
Yeah, I usually say like graph each
Gotcha.
line individually.
Got it?
And then step 2 would be like shade the overlapping region.
So you're going to graph each inequality. Separately. Did I spell that right? That looks wrong to me. I don't know. No E?
S-E-P-A-R-A-T.
Oh my God, this is embarrassing. Let's just get rid of that word. How about that?
S-E-P-A-R-A-T. Is it still E-L-Y or is it L-Y? Clearly, this is why we don't teach English.
Is that right?
Yeah, there's an E.
Oh no. How embarrassing.
You're still missing an A. You need to choose a different word.
All right, we're going to choose different. Can somebody give me a synonym for separately, please?
Or like individually.
I like that one.
Is that tricky too?
It is for me.
Maybe we need to go back to 5th grade and take spelling.
My mom's a retired English teacher too.
Oh,
She'd be very disappointed in my efforts. So you're going to graph each inequality individually, just like we've been doing. You solve for Y, you graph, you shade the region. And step 2 is going to be you wanted to shade.
Shade, darken.
Yeah, darken, especially if you have pencils. The overlapping regions. Which is a region. And this will make sense once we start.
Having the colored pencils, like kind of like using the iPad and having the colors helps. So
It does.
You have 2 different colored pencils so that you can kind of graph and use different colors to see that overlapping area a little better.
Yeah, it definitely helps. So what I'm going to do is I'm going to graph each of these 2 lines separately. So if the top one, my y-intercept is -5, which 1, 2, 3, 4, we actually need to put another point down here.
That's my fault.
Okay. Let's extend the line down and we're going to make a -5 point. From there, you want to go down 2 and over 1. Well, we can't really go down because then we're going to get into the work. So another option is to go up 2 and to the left 1. Does that make sense? We could problem solve this, no problem. And Michael, am I going to draw a solid or dashed line? Yeah, we're going to go dashed line. So you do want to be pretty solid on drawing your lines. If you have a pencil.
So here's where you want to take one of the colors of your colored pencils. Now we're going to try and start some shading. Pick a colored pencil.
And if we're shading, you really want to shade light. Very, 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 very light. So Michael, we're saying that it's less than, so we're going to graph shade what? Above or below? Well, so we pick a point, we go down, and we're going to shade this bottom region. If you're using a pencil, shade very, very, very light as you can. And it really helps if you, so we're using purple for the top, and then we can use like a blue for the bottom equation. That way you can see which one is which might help you out. If you're doing it on, I guess blue and purple are pretty close.
Yeah, maybe green.
Yeah, green looks good. That's much better. Yeah, those are blue and purple. All right, so now we want to go ahead and graph the second inequality. So what's our y-intercept here, Haley? 3? And then from there we go up 1 over 1, right? Or you go down 1 to the left 1. And you want to go ahead and draw your line. And Mike, let this be solid or dashed? Good. It's going to be a solid line. So now we want to shade in the same color or just really lightly. We want to shade below because it's y is less than. So we take a point and you're going to shade down below. Notice, this is what's tricky. Everything below this line gets shaded, so it is going to overlap. You want it to overlap the other line. It gets a little bit tricky. And you notice that now we have 4 quadrants where our lines meet. We have a left-hand side over here, an upper, a right, and a bottom. You're always going to get these 4 quadrants. So, Michael, where does it overlap? In left, up, right, or below? Yeah, the bottom one. So what you want to do is you want to shade that quadrant darker. So if you're using colored pencils or your 1 pencil, that's going to be your solution. It's going to be everything in that quadrant that's darker there.
Obvious. If we're walking around and looking, an answer should be obvious to anybody looking at it because it's darker than the location.
Questions on that? All right, so let's do another example. And again, I'll use the same colors just to be consistent. I think that this will help you be consistent if you're using your iPad, if you're using it on pencil. Again, just do it very, very light and then darken in at the very end. So I'll start with the purple equation or inequality. Y-intercept, what is it, Haley? From there, where I go, up or down? You got it. Up 2 over 1. Go down 2 over 1. Solid or dotted line? Got it. Haley, am I shading below this line or above the line? Above. Yeah, it's above. So you take a point and you go up. Okay. Now we're going to shade the other or draw the other inequality. So my y-intercept is -2. From there, I go down 1 to the right 1. Down 1 to the right 1. Michael, solid or dotted? Yeah. Am I going to shade above or below this line? Above. So here's the tricky part. It's real easy to think, oh, above, I'm just going to shade over here. It needs to be this entire region above. It needs to be over here, And it also needs to be over here. It's everywhere above the green line. And notice that we have this broken into 4 quadrants. And there's always going to be 4, and one of those is going to be your solution. Haley, where's our solution? Is it in the left, upper, right, or bottom? So where do they connect? Where's the darker region? Where do both shaded regions come together? Yeah. It's kind of this one up here. So now you want to go with your pencil, or if you're using an iPad, you want to darken that region. So it's pretty clear that that's the answer. It's going to be the darkest one. You even go.
Going to stop there.
Okay.
See if we can just practice a couple problems from the homework together. So if you want to take out your iPad, the worksheet is on Google Classroom. Mr. King, I don't.
Let me load it up.
It should be posted.
Not quite yet.
There we go. All right, so it should be on Google Classroom. You have to pull your screen down and refresh it. And then Mr. King, it is a notability.
Oh, you already have them?
Yeah.
Okay. I was going to bring it over. 4-3.
Yeah. Or not.
I could bring it in. No
I
problem.
thought it was.
It only takes a second.
I think you might have sent it
To
to.
reasons.
Where the heck did it go?
Oh, I don't
Should
know.
be under recents, right? If you
I
just
think
sent it.
reasons would be there.
Oh, right here it is.
Sorry.
Those are- we'll move it.
All right. Which ones are we doing here?
I think it's the whole work.
Okay. So we got some time to get started. So these ones up top, I'll just do one with you. You just want to check whether the ordered pair is a solution. So they give you, let's just look at -2, 1 for number 3 over here. So if we're going to look at that graph, all you want to do is plot that point. Here's our origin. You go to -2, 1. Is that touching that shaded region there? Michael? Yeah. Yeah, is it in there? Yeah. Or is that a dotted line? I'm having a hard time seeing.
Might be dotted. Yeah.
So if that is dotted, which let's make this one's, this is why I want to go over this one because it's a little tricky. See how that's a dashed line? If that's dashed, does anything on that line count as a solution? No. So this one would be no, because it's a dashed line. If we look for a solid line, like, nah, not that one. If we look at 2-1, is that in that shaded region? Yeah. Okay, any questions on 1 through 3? Number 4 through 6, all you're gonna do is just plug in, both of them have to match up. All right, these are ones I wanna do with you. Let's look at number 10 is a little bit different than we looked at so far. Okay, number 10 here, we have x is greater than or equal to -3. What kind of line is this gonna be, Michael? Solid, and is it vertical or horizontal, or? Horizontal. So we put it's on x is greater than -3. So at -3, you put a dot on the x-axis, and then it's going to be a solid line or dotted? Solid, good. So you draw your line down. And now this one's a special case because we cannot shade above or below a vertical line, but we can shade to the left or to the right. Michael, if it's greater, we're going to shade to the left or right? Yeah. So you just want to do a very light shade. Haley, what's my, where should I start to graph this second inequality? Yeah, you put a dot on +2, and then? Yeah, up 5/3. And you can also go down 5 and to the left 3. Solid or dashed line? Yeah, it's gonna be a dashed line. Again, you want to make your lines pretty dark if you're using a pencil, and then your shaded regions very, very, very light. Haley, am I going to shade above that line or below that line? Below, because it's a less than. So you just pick a point and then you go below that entire line. And that's why it's a little bit easier to use 2 colors. So you want to shade the region where the purple and the green meet on mine. Yours is probably a different color, but you want to shade the region where the 2 different lines and regions meet. Where would that be, Michael? Here, 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 here. How would you describe that? Yeah, like the bottom right, you're saying? Yeah, the bottom, the right-hand side. Absolutely. So then you want to take a darker color and shade where these meet. This could be all that region I outlined.
I know if you like kind of follow along the boundary line like he did.
Yeah, that's.
It gives you like a boundary,
Yeah, that's a good way.
along the dotted line, and then once you get to that vertical line, that would be your next boundary.
Yeah, so you make that, and then you can just go ahead and fill it in. Again, this is going to be your dark region that's going to be your answer. It should be obviously dark. If you're using a pencil, this really should be the only thing that pops out, is that region right there. Okay, let's do either number 11, number 12. What do you think, Michael? Let's do 12, yeah. Okay. So again, I'm going to make these 2 different colors. That way it's just easier to follow along. And we're going to solve. So I'll do my purple equation first. 3x plus 2y is greater than or equal to -2. What's the first step solving here? Subtract the 3x. And we get 2y is greater than or equal to -3 minus 2. And then you divide by 2. So you're going to solve here and then graph that way. That did go fast, huh?
So we're gonna do more of this tomorrow. We're not done. We'll do more on Monday. Have a fantastic day. Don't forget to review worksheet.
Yeah, submit it.
Submit that worksheet.
Submit that work.
Yeah, it was really good. I wake up at like 4 in the morning every day. I try to come in. I'm like,
4 in the morning? What you doing, Haley?